Standard 3D animation software simulates physical reality and optical perfection. Spider-Man Into the Spider-Verse operates on an entirely different logic, a highly stylized, intensely graphic aesthetic. This diagram shows how, out of the box, standard engines automatically generate a perfectly smooth, mathematically curved path between 2 points. They compute optical lens blur and calculate physically accurate light bounds. Slapping a 2D post-processing filter over this smooth output fails to capture the true comic book aesthetic. To achieve the desired look, Sony Pictures Imageworks systematically dismantled the rendering engine's core physics and mathematical rules. The new pipeline forces a dynamic 3D space to obey the static, handcrafted imperfections of analog print media, including visible halftones, registration errors, and line hatching. Achieving the Spider-Verse look requires a total re-engineering of the CGI pipeline to obey two-dimensional print rolls. This timeline grid represents the industry standard. In 3D film, a character's pose updates on every single frame, known as animating on ones. For Miles Morales' early scenes, animators placed him on twos, holding each pose for 2 frames, resulting in 12 poses per second. Having this animation data creates awkward, choppy movement that communicates Miles' inexperience and lack of control. This contrasts with seasoned Spider people, like Peter B. Parker and Miguel O'Hara. Both Peter and Miguel are animated strictly on ones, a continuous 24 frames per second that visually maps their combat mastery and fluid experience. Hobie Brown, or Spider-Punk, represents an extreme edge case in this pipeline, designed to mimic a hand-cut punk rock scene. Hobie is animated on 3s, giving him just 8 poses a second. His jacket and guitar operate on asynchronous frame rates for his main body, emphasizing his jagged, rebellious aesthetic. Here, frame rate dropouts function as a physical manifestation of character emotion and skill level. Dropping frames introduces a critical technical failure. It causes automated physics simulations to break down. This diagram shows how dynamic engines for cloth and hair struggle when they hit the blank gaps in a timeline. These systems require continuous spatial data on every single frame to accurately calculate gravity and momentum. When frames are skipped, these simulations behave unpredictably, jumping erratically or failing entirely. To bypass this, animators first posed the character smoothly on ones to satisfy background physics calculations. Here, you can see a smooth interpolated curve on a graph editor snapping into a rigid staircase pattern. Animators baked the animation splines and manually applied step keys to delete alternating poses, preserving solved simulation data while rendering the choppy aesthetic. Creating the illusion of a simplified, low frame rate style actually required rendering double the animation data and relying on manual overrides. To maintain the crisp ink-line aesthetic of comic books, production entirely banned traditional camera motion blur. Without blur, fast-moving objects rendered at 24 frames per second cause severe optical strobing. This test shows the stepping technique. To simulate speed without blurring, animators echoed or duplicated a geometric silhouette across consecutive frames. They also needed 2D-style smears and action lines to cleanly bridge these fast movements. However, drawing a 2D smear directly onto the screen fails in 3D stereo projection. To fix this, they engineered a custom incline tool. Animators draw a single stroke, and the software instantly generates a hierarchy of movable 3D control points along it. Maintaining this flat graphic look required inventing custom 3D geometry to replace standard optical phenomena. The shading pipeline faced the challenge of translating physical ink and paper into 3D light. They removed continuous tone lighting and soft specular highlights from the engine. Light intensity was replaced by arrays of floating halftone dots. Standard ambient occlusion and digital drop shadows were also eliminated. Instead, 3D line hatching was applied directly onto the character geometry to simulate shadows. The rules of the virtual camera lens also had to change, specifically optical depth of field. They looked to a physical error called misprinting, an aesthetic flaw derived from the mechanical rollers and sequential paper feed of industrial 4-color comic presses. In this diagram, you can see how a crisp CMYK image separates into its cyan, magenta, yellow, and black layers, then slides out of alignment. Sony replaced optical lens blur with this chromatic aberration, intentionally offsetting color channels on background elements. This technique mimics a misaligned printing press, keeping the central focal point razor-sharp while reducing background noise without a traditional lens blur. The mechanical limitations of a vintage printing press dictate every single lighting and camera rule used in the film. The ultimate compositing challenge of Across the Spider-Verse was integrating these entirely conflicting aesthetic rule sets inside a shared physical space. Gwen Stacy's Earth-65 represents the most extreme deviation from standard 3D rendering logic. This visualization shows her mood ring universe, where watercolor textures and palettes wash and bleed continuously from cool blues into warm pinks based on her emotional state, rather than physical light sources. Gwen's fluid world, Hobie's asynchronous 8-frame-per-second zine aesthetic, and Miles' halftone shading all function inside the exact same 3D scene without crashing the engine. Sony Pictures ImagineWorks shifted the technical standard for commercial 3D animation. This success grew from the decision to stop hiding behind the safety of photorealism. By forcing 3D software to struggle against its own design, baking simulations manually and overriding automated math, the team proved that this technical resistance is a powerful tool for visual storytelling. The ultimate achievement of the Spider-Verse pipeline was giving the 3D software back the one thing it was designed to eliminate: the visible hand of the artist.